So on 12 Days of Christmas, my true love gave to me 12 different things, and right about the time when she handed me calling birds, I started to wonder, do people actually want these things? This may be the perfect excuse to introduce a naive-based customer classification using choice data. Heads up, parts of it may be a little bit technical, so be warned. We marketers know that customer preferences vary, as much as their looks. Therefore, imagine the challenge a holiday shop has, trying to decide which of these 12 gifts to advertise to Christmas shoppers. This calls for a maxdiff analysis. I understand you may not be familiar with maxdiff analysis, so here's a quick summary of what it is. A maxdiff is usually an online survey in which a subset of a list of items is shown to customers, and they're asked to select the one that they like the most, and also the one that they like the least. The subset of items shown changes after each selection, and each person is asked to select about 10 or 12 times. The final result of a maxdiff is usually a ranking of the items, like here gold ring 1, well ahead of maids a-milking and geese a-laying, which beat the rest of the items in preference, with drummers drumming being the least popular. The holiday store would do best to advertise the winners and not focus on mentioning the losers. What we often find, though, is that individual results can vary quite a bit. This respondent preferred ladies dancing most, while another respondent preferred swans a-swimming very highly. There's a segmentation methodology called latent class analysis, which assumes that customers' choice patterns in the maxdiff questions can be grouped into distinct segments. How does latent class analysis find these patterns in answers to maxdiff questions? When a survey respondent finishes a maxdiff questionnaire, utility scores get calculated for each respondent and for each item that was shown in the maxdiff questionnaire. These utility scores look like random numbers, but they're really indicators of how much that respondent preferred that particular item in the maxdiff. What is actually a utility score? This is a bit technical, but necessary to understand how a utility score is used. The utility scores are what's called logit-scaled values or logged values, which once we exponentiate them will allow us to measure proportionality among them. In other words, allows us to calculate the probability of selecting that one item from among the total set of items. The reason this is useful because the math will allow us to calculate probability of selecting one item even if the total number of items changes, like in this example. Because utility scores produce probabilities, latent class segmentation also creates probabilities of segment membership. It basically calculates the probability of a survey respondent to belong to segment 1 or segment 2 or 3, and then assigns that respondent to the segment with the highest probability to belong to. The real value in segmentation is to be able to classify any future customers into one of the existing segments. What is the best way to do it? In this example, we have just done a survey with about 12 maxdiff questions, and based on these 12 maxdiff questions, latent class analysis assigned each survey respondent to a segment. In the future, we won't have the luxury of asking 12 maxdiff questions from our potential customers. They'd get frustrated and leave. We need a smaller amount of questions that will allow us to classify a future customer into one of the segments. And here's where Bayesian statistics can be very helpful. One approach called naive Bayes classification works very well. The main objective naive Bayes approach is asking, what is the chance of a respondent belonging to any of the segments given they answered one particular question in a certain way? Let's go back to our survey data and analyze them with that in mind. Bayesian statistics tells us that the new or updated information is proportional to the prior current information we have times something called likelihood. Okay, the new information we're after is what segment someone belongs to given how they answered a maxdiff question. The prior information is from our latent class segmentation, and then there's the likelihood. Let's talk about prior information. Let's assume 200 respondents answered 12 maxdiff questions, and based on that, latent class assigned each respondent to a segment like this. How about likelihood? It's a tougher concept, basically saying if a respondent belongs in a segment, how likely it is that they would answer a maxdiff question like this. For example, what is the probability that a respondent would pick partridge out of these 4 given he is in segment 1? To help us figure that out, we need the utility scores again, but this time we need to also use the utility scores for segments as well. These are respondent scores averaged by segments. As showed earlier, we can turn utility scores into probabilities of selecting among the subset of these 4 items, here both for a respondent and segment 1. In this example, this particular respondent has a 47% probability of picking partridge out of these 4 gifts, while a typical segment 1 person would have a 45% probability of picking. The probability of both the respondent and segment 1 picking partridge is the joint probability, 21% here. Summing up the joint probabilities is 36% that this respondent would make choices like segment 1. The probability that this respondent would make choices like segment 2 is 26%. The probability that this respondent would make choices like segment 3 is 14%. We now know the likelihoods, the probability of making choices given respondent belongs to a segment. What we're after is the probability of the respondent belonging to a segment given they've made choices in a way. For that, we use the Bayes formula, where we use our latent class segmentation probability with the likelihood, which tells us which segment the respondent should belong to, given his answers to a very limited maxdiff question. Now the question becomes which maxdiff questions to use to classify future respondents. Notice in our case both the 12th question maxdiff and the naive Bayes from this question set classify this respondent into segment 1. Well, we need to look at, is this set of questions the one that classifies respondents correctly the most often? Or are there other combinations that have a higher accuracy in matching the original segment assignment? The set of questions with the highest match rate wins. And that is naive Bayes classification in a nutshell. Hope you enjoyed it. Happy holidays, and come and visit our website and subscribe to our channel for more cool nerdy stuff.